Good morning, sleepyheads. I am also sleepy. But that's because it's like super late at night. So I am gonna go to bed after this. After we get these notes done for 7.3. Alright. Ooh, I have a surprise for you. See if I can find it again. I found my high school yearbook. Are you so excited? We were the Tigers, Northwestern Tigers, Maple, Wisconsin. And this is my cat. Get out of here. Move. Okay, and this is my senior photo. Tried to get that glare right in the middle of my face. That's actually not me. That is apparently Autumn Olson, who graduated with me. That, not to glare, that's me right there. I showed this picture once to a student, and he said, "Oh, Miss Nussbaum, you used to be so pretty." Yeah, it's pretty heartbreaking. But yeah, the problem there was the word "used to" and not "pretty." But here's something that some of you have probably seen that picture from different prizes and stuff like that. But here's one you probably haven't seen. It's a baby picture of me when I was a little girl. Crazy curly hair. No idea what was going on there. And right here, very straight hair. Very long straight hair. That was apparently before I just dyed my hair like crazy every year, once a year, and destroyed it. But I feel like that's really your fault, not mine. So I'm going to go ahead and blame you guys for me not having beautiful hair anymore. Okay, let's talk about 7.3, some hypothesis testing for a unknown sigma. Very exciting. I mean, the cat is literally right there. They're just right here. This is Sparkles. Say hi, Sparkles. Yep, she's down. Okay. So the difference between a t-test and a z-test is that for both of them, you need a normal population, or you need n is greater than or equal to 30. So I'm going to write that on both sides. These both have to do with testing means. And the next section won't. There's actually 4 kinds of hypothesis tests you can do. The first one is a z-test for a mean, the second one's a t-test for a mean, then you've got a proportion, which we'll do next, and then testing a standard deviation, which we will not do because it's not on the AP test, but it is something that you could do. Okay, this is when you know your population standard deviation. And this is when you don't know. That noise, by the way, that I just recorded the algebra video, and this noise was in it the whole time. That is my cat eating very loudly. Couldn't talk and write at the same time, apparently. So you don't know the population standard deviation. This is more likely. This is what's going to happen if you end up being a statistician or anything like that for a company. You're going to be doing t-tests a lot because it's rare that you're going to actually know the population standard deviation when you're testing a sample, unless you have data from like a previous study or something like that. This one you use A16 and z-scores. And this one you use A18 and t-scores, which we're about to do today. Alright, this time I decided to do things a little differently. Instead of making that normal chart that I do for you guys with all the steps, I just wrote down the steps, and then I have an example that we can do with the steps at the same time. Then I've got 2 more examples we're going to do that were kind of just slightly different ones, so you get an example of each, and then 4 homework questions, and we are out of here. Killing it. Okay. Here we go. I'm going to turn to page A18 in my text because I know I'm going to need it. Alright, a used car dealer ship, I guess, says that the mean price of a 2-year-old sedan in good condition is $20,500. You suspect this claim is incorrect. Find a sample. I'm just going to start writing down data that I see. So the sample is 14 vehicles. The X bar, when they did that test, it was $19,850. The sample standard deviation is $1,084. Alpha, that level of confidence, is 0.05. Degree of freedom, which we will need for this. Remember, that's just n minus 1, so that's just 13. Alright, we've got a null and alternative hypothesis. It says the mean is 20,500, so that means it equals 2. Opposite is not equals 2. Top one is the claim. Kitty is enjoying her food.
How loud can you be?
Yeah. Alright. Next we're going to identify what test we should use. So again, it's two-tailed, left tail, or right tail. And because this is an equals 2, this is a two-tailed test. Level of significance, degree of freedom, I already got those there, so we're good there. Critical values and rejection regions. Now you actually can do a t-test with, it's pretty hard because, so you know that there are two kinds of ways you can do a hypothesis test. We did rejection regions 2 days ago, and then yesterday we did, a few days ago. So we did rejection regions, then p-values. One is to do with a z-score, and one is to do with area. But if you look at the t-score chart on page A18, you see that there aren't any areas on this at all.
So loud, Kitty. Quit it.
Okay, so there's no areas on this at all. You actually can do a hypothesis test using your calculator. There's a program on the graphing calculator to do that, which I'll do with you guys in a couple days. And that you can do a p-value. But in the book, you can only use rejection regions if you're using a chart, which is also what you'll have a calculator and a chart when you're taking the test. So anyway, critical values. Maybe I should just draw a picture down here right now. Okay, this is a two-tailed test. Here's my H sub O in the middle. These two add up to, what, 5%? So this is 0.025 here, and this is 0.025 there. In the area, in the tails. And then we need to look up the critical values. So the critical values, or for the rejection regions, are, let's see, our degree of freedom, which was n minus 1, is 13. So I'm going to go to 13. You guys can see. 13. And then up here, remember before we were just using that level of confidence, now we've got one tail or two tail. This is a two-tail test, and it is 5%. So I'm going to go to that middle column there, which makes sense because one tail is 2.5%. And that is a t-score of 216. So I'm going to use 216, positive and negative on either side. Okay, those are the critical values in the rejection regions. A t-test, x bar minus mu over s divided by the square root of